This is number 53 for chapter 5. A time-dependent force F equals 8I hat minus 4tj hat newtons, where t is in seconds, is exerted on a 2 kilogram object initially at rest. Part A. At what time will the object be moving with the speed of 15 meters per second? B. How far is the object from its initial position when its speed is 15 meters per second? Part C. Through what total displacement has the object traveled at this moment? So, diagram. Object 2 kilograms, and there's a force acting on it. But this force is time dependent, so it varies depending on the time. But we know that the sum of all forces acting on an object equals the mass times acceleration. So if we solve for acceleration, which is the force divided by the mass, we'll get 8I hat minus 4tj hat newtons divided by 2 kilograms, and this equals 4I hat minus 2tj hat meters per second squared. So part A asks, at what time will the object be moving with the speed of 15 meters per second? So we want to find an equation for the velocity that is in terms of time. So the velocity is going to be the integral of the acceleration, which is 4I hat minus 2tj hat. And this will be 4ti hat minus t squared j hat. And you know there's no constant because when t equals 0, the velocity equals 0, and that is true because the object is initially at rest, as stated in the problem. So, we know that velocity has two components in this case. So there's velocity in the I hat direction and velocity in the j hat direction, and the resultant velocity is just v. Since this is a right triangle, we know that v squared is going to equal v I hat squared plus v j hat squared. And then if we just plug in numbers, we get 15 squared equals 4t quantity squared I hat plus t squared quantity squared j hat. So if we move this all to one side, then we get t to the fourth plus 16t squared minus 225 equals 0. So this is a quadratic equation. So if we use the quadratic formula, we get that t squared equals negative 16 plus or minus square root of 16 squared minus 4 times 1 times negative 225 divided by 2 times 1, so you'll get that t squared equals 9 or negative 25, but that's not possible because time is positive. So t equals 3 seconds. So as you see here, we plugged in 15 meters per second for velocity. So this time is the time when the speed is 15 meters per second. So that answers part A. We'll do part C before part B actually. So part C asks what the total displacement is, while part B just asks the distance. So displacement is a vector, and if you remember from part A, velocity equals 4ti hat minus t squared j hat. So the position vector r is going to be the integral of 4t I hat minus t squared j hat, and so this equals 2t squared I hat minus 1 over 3 t cubed j hat. And we no, there's no constant because when you plug in 0 for t, you get 0, and we can say that our initial position was 0. So yeah, no constant. And then you plug in 3 because we know that the time is 3 seconds when the object is at 15 meters per second. So when we plug in 3 seconds for time, we get that the position vector is 18 I hat minus 9 j hat, and this is meters. So this is part C. And we did part C first because part B asks how far the object is. So that's just the magnitude of the position vector, which equals the square root of 18 squared plus 9 squared, and that is approximately 20.1 meters. And that's part B. So that is number 53 on chapter 5.